Hello, everyone. Thank you for joining us today in this new meetup. First, let me quickly introduce the group. Is there anyone here that is the first time that you come to the Madrid Groovy user group or Madrid Java user group? Okay, welcome. Just to introduce the groups very quickly. So we are two different groups. I'm Ivan from the Groovy user group, and then we have David and Ignacio from the Java user group. We've been doing joint meetups for a couple of years now. So you have there all our contact information, Twitter, Mastodon, Meetup. So if you are interested in learning something about Java, about the JVM, about the whole ecosystem, you are in the right place. So welcome. Thank you, Globo, for hosting us. We've been doing a few meetups here. They are very nice. We will have pizzas at the end, so don't leave, and we can talk a little bit after the meetup, right? Because this is not only about the talk; it's about the community. It's about knowing us a little bit more, talking about a different things. So please don't leave just after the talk. And that's it. We have today Laurent. Did I pronounce it right? Laurent. My French is not very good. Auri should have been here presenting because she speaks French. So he has been doing a tour, an Iberian tour, going to a lot of JAX in Spain and also in Portugal, talking about Couchbase and Springboot. He's a developer advocate at Couchbase, right?
Sorry?
You are a developer advocate at Couchbase. He's going to introduce himself. So basically that's it. That's it. All yours. Thank you.
Right, thank you. Cheers. We'll go with the sound. Yes? Awesome. Let's go. So, that was me. Should be good. All right. So that's me. My name is Laurent. I live in Paris, in France. I manage the developer relation team at Couchbase. You can find me on various social networks with always the same handle, LDOGUIN. The first one's supposed to be GitHub, I think. There's 8 legs, but it's not a cat. GitLab, it's a fox probably. That's what used to be Twitter. And La Marmotte Masquée is the name of my brewery. I have a brewery with some friends. We brew beer. It's available in Grenoble in France and in Paris, and a bunch of other places. So if you like beer. I'm going to start by a question. And not everybody has that problem, but usually when I ask the question, people raise their hand. Is there anyone that uses more than 2 data store? And by data store, I mean database, I mean cache, I mean streaming service like Kafka. Is there anybody that's using more than one? Can you please raise your hand? And that's 1, 2, 3, 4, 5, 6, 7, 8. Almost everyone. And that problem is called data sprawl, which basically means you have all those data sprawled around so many different solutions. Different kind of solution. You have caching solution like Redis and Memcache, Membase. You have NoSQL database. You have relational database. What's the difference? No one knows because now every relational database does JSON and every NoSQL database does SQL. So how do you make a difference? I don't know, but they exist. We have query tools like Power BI, stuff like this. We have geo-application features. There's a whole bunch of things in there that you might be using. A lot of eventing recently has been very popular, analytics or real-time analytics. And then there's the weird thing at the end that few people use, but it's getting more popular, which is mobile. Maybe you use Firebase or Realm, stuff like this. And they all come with their own set of challenges, right? You need to learn how all the solutions that you use are working. Then you need to learn how to make them work together. Then you need to sometimes pay for them, get the support, get the training. And so it's kind of a lot of work. What if there was something simpler to do? And that simpler thing to do is a small demo that I'm going to show you. It's a very opinionated demo with a very opinionated use case. Instead of boring you with business code like travel industry or whatever, I chose something very simple. I have a CRUD interface, a cache, a query, and a search interface. I need to cache stuff, create stuff, query stuff, search stuff, all right? And there's 3 different kind of architecture that you see here. And each time there's a link that's one thing to operate and one thing to think about and one thing to write code with. So the first one, if you want to do CRUD, cache query, and search, you need to use probably a full-text search engine. If you need to do cache, you probably need to use some sort of caching store like Redis and Membase. Then you probably need to use a document database or a relational database. It's all the same thing now. And then you can sync all of them through an eventing service like Apache Kafka, Apache Pulsar, all that stuff. And then you need to write the code to actually use them, and then you have dependencies between some services because, of course, CRUD service is first going to actually ask the cache if the thing's in cache and then send you the answer. And if it's not, there's a bunch of interaction between each services and each data store. On the first one, the data store are being synchronized with the event streaming solution. On the second one, we get rid of the event streaming solution because it was too expensive. And so now we have to manually sync all of these. So that's more interaction between services, less things to manage, less things to buy and think about. What if there was something simpler and easier and, oh my God, Couchbase, yay! So there we go. This is going to be the first demo. And that's going to be me showing you how Couchbase is both a document database, NoSQL database, caching system, search engine, and a bunch of other things. I hope the code is big enough. Let's see, voila. So what do you do when you have a cache? Most of the time you write something in a cache, you read something from the cache, evict, you remove something from the cache, and sometimes you update the time to live of what's in the cache. Pretty simple stuff. CRUD, it's pretty much the same thing. Create, read, update, delete. Upsert is a little less known. It's update if it exists or insert a document. Then you have an interface to query things. And then you have an interface to search things. And in the search interface, you can see that we also have, we have the search method, but we also have something to index a document, so put something in the index, in the full text index, or remove it from the full text index. All right. So a naive implementation, and everything here is very naive because I just want to make a point. In reality, it would probably be more complex. But let's pretend you have a Mongo or Postgres or whatever based CRUD interface that needs to do all that stuff. And that doesn't have the event streaming to synchronize everything. So first of all, you see that there is a dependency from the CRUD service to the cache and search service. And then when you read something, well, let's first read it from the cache. Hopefully it's in the cache, so it's in memory. If it's not, well, you get it from the database, you write it in the cache. If it is, you update the time to live, which is the time it's going to stay in the cache. Very simple stuff. If you create, update, or delete something, or observe something, you need to reflect it in all the other things. That means that you need to put it into the database, put it in the cache, and search it, and index it. So all of this, you have to think, man, that's a very simple use case. Usually it's more complicated than that, but you have to think about these things. You have to do them, maintain them, and we all know that writing code is not the most expensive thing there is. The most expensive thing usually is you have to maintain all the code you wrote. That's not great. And if I go to Elastic, I can see a search function that you see here. It's a basic search function. And index and delete, which remove all that stuff from the index. So all of this you have to think about and you have to do. Usually it's more complicated. The way you would do this with Couchbase, let's talk about search first. You can see that index and delete are not implemented because you don't need to. There is no cache because the cache is automatically integrated into the data service. More on that later. And so if I go to my CRUD interface, There is no dependency to the search service anymore. There's no dependency to the cache service anymore because all of that works automatically. Which is what you see here. It's just there's a collection. I create, read, update, delete, upsearch things from the collection. Something fun to talk about as well in the search. You can do what I would call an elastic-like search, which is like you run a search, you use the API, you use a search query, or because everything is fully integrated, and because Couchbase is also a NoSQL database .SQL, you can write a SQL query. So I'm selecting a bunch of fields. I'm adding something which in that SQL query that says use the full text index, and then just add my full text query part. And if you think about it, that's quite nice because usually what people do when they have several data stores is that they would do a query to Elastic. Elastic would give you a list of IDs, probably. Maybe they would give you everything because you have covering index. That's great, maybe not. Assuming it gives you everything, and I mean everything, that's amazing. Usually you don't have the security and permission of the documents that are indexed in Elastic. That security and permission table is on the document side of things, or the relational side of things. So once you have those IDs, you get them, and then you do another query to the document database or the relational database, and you do a manual join because all those IDs that you get, all this information, you need to make sure that the current user actually has the right to read them. So you add another filter basically, and usually people do that manually. Here is just another where clause, which is very cool. Now, why does it work? Let's talk about, Couchbase architecture and all the stuff that Couchbase do. If you remember the first schema I showed you, there was a bunch of databases, pretty much the same schema, but using features instead of products. So Couchbase has an integrating caching system, so everything's in RAM by default. It's a key value store. You can store JSON documents as value. If those values is JSON, then you can do SQL query, you can do full text search, you have operational analytics. Eventing is like user-defined function or triggers for classic databases. If something happens, then do whatever. Then we have mobile and edge. Now, usually when you say, I'm doing everything, people tell you, well, you cannot be doing everything, you're just a database. Well, and that's true, that's a valid concern. There's one thing that's very important, and we must not forget. The way you store something defines how efficiently it will be retrieved. Meaning, one of the first things you actually learn in computer science course is data structure. They tell you the difference between a hash map and an array or a list. And you store things differently because you want to do different things with them. It's exactly the same for databases. And so what we did is we've added different services that store things differently so that you could query them differently and more efficiently. So the trade-off that we did, we didn't compromise on one data store and several models. We actually compromised on a somewhat complicated architecture that has one store per querying model, which is what you see here. We have a caching layer, a caching system, so everything's in RAM, and then behind that you have the data service, the query service, the index service, the analytics service, full text, eventing, etc. Storage layer. The cluster manager it's kind of our own zookeeper, if you know zookeeper. It's the thing that makes sure that every node of your distributed system agrees with each other. It's written in Erlang, or was written in Erlang, I'm not sure if it's Erlang anymore, for some reason. Because Couchbase, does anybody know why it's called Couchbase? So first of all, Couch stands for a cluster of unreliable cheap hardware. It comes from CouchDB. CouchDB was an Apache project started by Damien Katz in 2005 or 7, started before Node.js. Let's think about this, before the web was all JSON and REST. And CouchDB was a JSON database with a REST API. Before, like when people were writing SOAP and WSDL and stuff with language, type language. So that was sort of impressive. And then Membase. Membase was the distributed version of Memcache. Memcache was a key value store in memory. And so they've merged the two products. Some people would say fork, but they've merged CouchDB and Membase and created Couchbase, which give you a distributed database with an in-memory layer, so a cache, key value. And in CouchDB, you would query documents by creating views, and views were a manual index. You were writing a MapReduce function, and it will create an index, and then you would query that index. It was not great for ad hoc querying. If you don't know what you want to query, if you want to explore something, then it's hard. Like, you have to create your index manually all the time, which is not great. So we've ended up adding more and more features to that merge of CouchDB and Membase, which is Couchbase, and now we have proper SQL, we have analytics. We just announced today, was it yesterday? I think it was yesterday. A new real-time analytical store as well, to do any kind of SQL and had a real-time answer. So a bunch of services that have been added over time. Basically, we have an architecture that allows us to add new stuff all the time. So if you start with Couchbase, we like to say that it's a bit future-proof. Everybody's talking about vector search right now, like in the database world. A vector search is sort of a specialization of a full-text engine. So for us, it's going to be pretty easy to add to our existing system, because Couchbase is made like this. And if there's new use cases coming up, then it's going to be easy for us to add it. It's going to be easy for you, if you already use Couchbase, to keep adding them. You don't need to use everything at the same time. You can start with just data, and then you can enable what you need as you go. The way it works is a bit like this. We have an architecture called multidimensional scaling, which is just a big word to say that you can scale out or you can scale up. You can have as many nodes as you want. You don't have to activate every services. Some node will scale up more. It will be more interesting to scale them up. Scale up means bigger machine. Scale out means more machine. So in some cases you want more machine. In some cases you want bigger machine. Let's take the query service, for instance. The query service is a stateless service. Its goal is to take the SQL query and parse the SQL query, create the query plan, and do all the crazy things that a SQL database does. Realize that there's an index here, the index is there, and then the data are over there, and get that data, create the projection, which is your select clause, which is JSON. That's pretty CPU heavy, so you will probably load up on CPUs for the query service. And then on the index service, what you want to do is make sure that you have enough RAM to store everything in RAM so that you can answer fast. And then maybe you want to shard your index as well, because sometimes you need to distribute your data, which is also what we are doing on the data service, but I'll talk more about this later. Do you need search? Maybe you do, maybe you don't. If you don't activate the full text node, that's all. Basically, you can scale in any way you want, with any kind of machine you want, and they can be completely heterogeneous. Fun fact, if you have GPU on your analytics node, because we have user-defined function that can be written in Python, unfortunately not in Groovy, but maybe one day, if you do some Python that does some interesting thing with GPUs, like machine learning or whatever, you can upload that function in the analytics nodes, and you can run that Python code that uses your GPU on the nodes where the actual analytical data is, which is quite nice. And so how does that work? What's the first thing that makes it work? It's a database. The most important thing is storing data, so that's the data service. So we're going to zoom in a little bit on the data service. I say it's a key value store. The value could be anything. It could be a string, could be binary, could be whatever you want. But most of the time, what people do, in order to use all these other cool services, is store a JSON string. If you think about it, a JSON is it's a string that holds its own table, its own SQL table. If you think about it, it has fields. A field has a name, a field has a type. Some types are more complicated than others, but basically it looks like a table in columns. It's just that every JSON has its own table, really. So that's what we have. We have lots of documents that each have sometimes the same, sometimes a different table, and this table can change all the time. That's what JSON allows you to do. And so the way we've decided to store things can be loosely mapped to a relational database, in the sense that in a relational database, you have a server, we have a cluster, and then a database would be a bucket, a schema would be a scope, so that's where you would, for instance, you would separate multi-tenancy. If you want a multi-tenant application, a scope is a good granularity for that. And then you have collection, which is like a table, which is also very close to what Mongo uses as collections. And then your document would be the line of your table, and then the field would be the actual value. It's important to have a sub-document access to a document. There's a lot of databases that only work with a document in its entirety. When you do a SQL projection, you only select the field that you want. You don't want to, get the whole document each time. And if you work with big documents, then it can clog up your network pretty fast. If you retrieve every single document of your query, the whole content, it's a bit heavy on your network. So subdoc allow you, for instance, to not do that, which is good. And so the way it works, because it's distributed, you need to find a way to distribute the data. And it's called sharding. And we provide automatic sharding. There's a lot of database that makes you come up with your own sharding key. We don't. We have our own way of doing things. So we sort things into bucket, scopes, and collection. And each bucket is separated into 1,024 virtual buckets. So think of it as shards, really. And the moment you write a document to the database, it's a key value pair. So based on the key, I really hate animation because I never know when it stops. Voila. Based on the key, you can create a hash, and the hash that starts with something and finishes by something else is attributed to virtual bucket 1, virtual bucket 2, etc., etc. So it means a couple of things, but basically, to write something, we get the key, we apply a CRC32 hash, modulus the number of virtual buckets that we have, is going to give us a virtual bucket, and then the client knows where each virtual bucket is on which machine, so it knows where to read it, or write it, or update it, etc., etc. This comes with a couple of constraints. If you want this to work, the hashing algorithm and the distribution logic, the sharding logic, must be common between the server and the client. So it means that we have a stateful protocol. It means that the way you write something to Couchbase is you need to use the Couchbase SDKs, basically. There's not a REST API that's going to just work. You need to get the key, hash the key, get the virtual bucket, and you need to know where each virtual bucket is. And in order to do that, we have something called a cluster map. So each time you initiate an SDK connection to a cluster, you open a WebSocket to the cluster, and each time the cluster map is changing, the changes are being pushed back to the client. This is, for us, that's a way to know where each virtual bucket is, but also where each service is. As a client, if I'm doing a SQL query, how do I know that the query node is, how do I know its IP, its port, etc., etc.? All this information are in the cluster map. We know where are each buckets, we know where are each services, we know where are each virtual buckets, scope, collection, etc., etc. So it is a stateful protocol. Right. Here's an example of a traditional architecture. You have application servers, you have a cluster map, which is basically a map of this, but even more with a finer granularity. And here you can see a couple of things that are interesting, really one thing that's interesting. There's one bit that says active and one bit that says replicas. And the reason for that is Couchbase is a masterless architecture. There's no master node. All nodes are equal. They all have a controller. They all know the state of the cluster. And they all own one active version of the data at one time, which allow us to be strongly consistent. You have also databases that have several active versions of the data at the same time. So if you want to have a consistent answer, you need to have a quorum, which means basically interrogating more than 50% of the nodes to make sure that you have a consistent answer according to the cluster. So that means more things to do. With Couchbase, if you want to get an updated version of, an up-to-date version of your data, all you need to do, because there's only one active version of that data, is get it. And usually it's in RAM because we have this integrating caching layer. So usually you get a sub-millisecond answer time because of that. So it can be extremely fast and strongly consistent. Every data is replicated 0, once, twice, thrice, or 4 times, depending on how many nodes you have. It's probably useless to replicate everything 4 times if you have 3 clusters. And what's important is how do you manage changes in your cluster. You know it's a distributed system. You know that in distributed system, the more distributed you are, the more machine you have, the higher a risk of problem is, because you have more stuff, so statistically you have more chances to fail. So of course you need to be replicated to have replicated data, and you need to change the distribution of all that data when you need to add nodes, or remove nodes, or when you lose a node. So how does that work? Is there an animation here? I don't remember. No, there's no animation. Thought there would be. When you add 2 nodes, imagine that all the replicas here are going to be equally redistributed, and in all the virtual buckets, all those virtual shards are going to be replicated in the background. And the moment it's replicated, the moment the cluster map is in a consistent state, we can push automatically the cluster map through the WebSocket to all the clients so that they know that the distribution has changed. Rebalancing data, we call that redistributing data, is called a rebalance if you have one node and you do it, and you're doing it willfully. There's a couple of things that you can do. So rebalance is, and you can do rolling rebalance, is I'm adding nodes, I'm redistributing data. It's a long process. The process duration sort of depends on how many buckets and scopes and collection you have. Basically, the more granular you are, the faster it can be, because we move things based on collections or scopes or buckets instead of moving everything. When we only had buckets, it was a bit slower. Now that we have different granularity, it's easier and faster. If you want something to happen quickly, that's called a failover. We only allow one node by default to do a failover, an automatic failover, which is basically you have 4 machines, someone unplugged one of the machines. Now you have 3 machines, you've lost a fourth of your active data. Fortunately, they were replicated in every other node. So a failover means immediately the things that were accessible as a replica are now accessible as an active version of the data, and that's immediate. Don't do too many automatic failover, because if you need to do too many automatic failover, it means you probably have a real problem of, it's often called a split brain, which is when let's say half your cluster doesn't see half of the other cluster. So imagine you have 2 racks and a network connection between the 2 racks doesn't work anymore, so one rack doesn't see the other one, so they're like, where's the rest of my database? And there's probably something manual that you want to do instead of just redistributing everything. We also have a Kubernetes autonomous operator that allows you to do automated pool replacements, automated rebalance, and all that kind of stuff. So what happens if you lose a node? The cluster map is lost. Automatic failover. The shards that we have lost on the active version were replicated here and here and here, and they are now automatically being promoted as active. Everything is magical, everything works. That was, in a very fast, what time is it? A pretty fast introduction to Couchbase. Do we have question online, or do we have question in person before I dive into the Spring stuff? All right. I just launched something in the background called Open Telemetry Desktop Viewer. It's an in-memory database that allows you to record Open Telemetry data. Open Telemetry is a standard that allows you to record metrics, traces, logs. I think the logs has been added very recently. to that standard. So it's a way to configure your SDKs or your software to automatically send stuff to a database and to visualize this. Most of the projects that exist usually come with a Helm chart or a Docker Compose that starts like ClickHouse and Zookeeper and a whole bunch and Graphite and Grafana, and like it's too much for a developer machine. But this thing, OpenTelemetry Desktop Viewer, it's available on GitHub. It's just very simple. It just works. So if you want to use OpenTelemetry while developing, it's great. I'm going to change to a different project. I'm going to show you some code, some Spring code that use Couchbase. Whoops. Gonna start by showing you some of the stuff that are not necessarily Spring related, but make Spring usage pretty nice. And that's a couple projects. The first one is test containers. Spinning a Couchbase container can be a little bit complicated because when you start a node, like when you start most databases, usually they're ready to be used. If you do Docker and Redis, you can start using curl and it just works. Couchbase is a little more complicated because you need to, because of this platform approach, because of all the services, well, you need to configure them. You need to know if you're starting a new cluster, if you're joining an existing cluster. So we created our own test container Couchbase project to allow you to do that pretty easily. And it works like this. Here I have a JUnit extension. And the way it works, it takes my metadata, and there I can tell the size of the memory I want to locate, for instance, the data service or key value service. I can say I want the query, index, search service, etc., etc. I can pre-create buckets. I can pre-create a lot of stuff. Now, the best thing to do to pre-create lots of stuff might not be to do it in your codes, in your unit tests. There are some projects that are very cool for that and that actually exist for that. And one of them is called Liquibase, and we have a Couchbase Liquibase. It's been contributed by the community, and it's pretty cool actually. Whoops. I'm not sure if you're familiar with Liquibase. It's a way to create change sets. It's usually attributed to relational database because with relational database, you have structured data. If you have structured data, that means you need to create a schema, table, columns, all that stuff. With Couchbase, because it's SQL and because each JSON document holds its own internal table, then we don't really have that. So does this make sense for the SQL database, for schemaless database? Some people would say no. I would say yes. There's a whole bunch of things you can create automatically. And so our Liquibase projects allow us to create buckets, scopes, collections, and something I haven't talked about. If you remember, there was a query service and there was an index service. And for the SQL query to SQL service to work right, the query service to work well, you need to create primary index for each thing you want to query. So here I can automatically create my primary index for all my collections, which is what you see here. You can also preload some documents. I mean, there's a whole bunch of options that allow you to programmatize in a repeatable fashion the way you would kickstart the content of a Couchbase cluster. So that's pretty cool. So that's one of the things that are supported by Couchbase. So now let's go to my Spring application. I did a whole bunch of things, but this one is probably the most interesting. And it says enable transaction management, which means that Couchbase can have transaction. It's a distributed database that supports transaction. And that's great, because no one wants to do manual transactions. Let's say, where do we start? So Spring, if you're using a database, you probably know the Spring Data projects. And Spring Data or Spring So Spring Data is all the ODMs project, Object Document Mapper, and there's also Spring something for all the ORMs that I forgot about, Spring JDBC, Spring Hibernate, Spring whatever. Anyway, Object Relational Mapper, table and columns and relations. When you use an SQL database, you use an ODM. So Spring Data Couchbase, you're mapping documents to your document database, which is why you see document annotation here. I want to make sure that every user record are going to be recorded into default scope and the users collection. Of course, everything can be changed. We support Hibernate validation as well, which is super nice. And then the rest is pretty basic if you already know Spring and Spring Data. You can see here that we have a version field. That's actually quite nice. Every document you store in Couchbase has a compare and swap number in its metadata. When you store a key value pair, there's the key, there's the value, and something I haven't talked about, it has metadata. And one of them is a compare and swap number. And what it allows you to do is optimistic locking. When you want to do pessimistic locking is basically telling the whole database, I'm locking these documents, nobody else can use it now, it's mine. Which means that nobody's going to be able to modify it while you are locking it until you've unlocked it. That's the pessimistic way of doing this. The optimistic way of doing this, you can do it with a compare and swap number, a cast number, which is what you see here, and that's what add version allows you to do. Basically, you have a version number that starts with 1 whatever because you just created the document. So it's the document you have on the client as 1, the document you have on the server also as 1. And you have 2 clients that are going to do the same write. So the first client succeed, is the first one to write it. So it changes the value that was 1 dash something to 2 dash something, and then 2 is returned to the first client. And the second client, that was a little late, and they're still coming up with 1, ends up on the server, and the server tells, well, actually, it's 2 now, so I'm going to send an error because your compare and swap number is different than mine, so it's not consistent. And so that's how you would do optimistic locking with Couchbase. And it can be automated with version, and that's also what you can use. Like you have to have this if you want transaction support. And of course, we have repository. A repository are a way in Spring to make sure that you can automatically create queries based on the name of your method. So if I have a method that's called find by mail, I know it's going to return the object typed into my interface. Here it's a user. And by taking a mail, so it's going to generate a query automatically. Sometimes it's good, it works. Sometimes, because, using ODM, why would you use an ODM? Because it makes your life easier, faster, and all that stuff. The reason it's easier and faster means that they make choices for you. It's a trade-off, like everything else in tech. And sometimes the query that's automatically generated is not that great, and maybe you can do a better version of that. So we also support the add query annotation that allow you to, for instance, here it's going to do the exact same thing. But I could, if I was using an index, okay, if I had an index, I could actually add here, I guess, you could specify which index to use, so that would optimize the query. That kind of stuff you can do pretty easily. So let's see. I'm gonna start my application, and this is a very stupid application that hopefully is working because I've started my cluster. Maybe, maybe not, we'll see. And what the silly application does, there's a bunch of methods that does the exact same thing and that are executed every 2 seconds. And so we're going to see, thanks to OpenTelemetry Desktop Viewer, which one is the fastest and explain you the differences between all of them. So it should be starting, that's great. Whoop, let's go here. So this is a manual SQL query that's returning every field of the user document, a user JSON document that is stored into the default bucket, default scope, users collection, where melt equals blah, blah, blah. And so you can see that I get query results. I can deserialize it into my user objects. A bunch of work that can be summed up pretty easily by using a user repository that does the exact same thing. Another way to do this, which is interesting, is do not forget that Couchbase, first and foremost, is key value database to which we validate a whole bunch of stuff. And something that's important to remember is that 2 key value operation, or 3 or 4 or 5, are probably always going to be faster than a SQL query. If you do a SQL query, you're doing a REST, you're doing an HTTP post, I guess, to or GET to the query service. It's going to parse your query. It's going to analyze it. It's going to realize which index, where to get the data, get that data, get the projection right, and then send you back the data. So we're talking we're talking about a bunch of CPU cycles just to, get that user object. If you did your data modeling right, and if you created what we call manual secondary index, that could be much faster. And that's what you see here. Here you see that a first get is used to retrieve a string. And the key of the document is the email. And the return string is the user ID, the ID of the document that actually all the users. So what it allows you to do is do 2 key value gets, all of them sub-millisecond, to get that user document instead of using a SQL query. Now the downside is, each time you create a user document, you need to create another document, which key is the email, and ID is the UUID of the user document. If you think about this, as a user, when you log into a website, usually you don't remember your UUID, the ID of the document representing the user that's been created automatically by the system. So you use your email address, right? So you could get it through a SQL query, or because you know that everybody's going to do that, you can just create the user document and another document, which key is the email and value is the ID. And then you do those 2 key value gets. And you know it's going to be faster, dramatically faster. One way to do this, you can do just an update like this, which is basically, I have my document, I have my key, sorry, the key is the email, and the value is just a string that holds the ID of the user document. Let's say you just created the user document and you want to do a query right after that. And the creation of the user was just a key value set. But you're running a SQL query to create the secondary document. That all SQL query is going to take some milliseconds to happen, right? So there might be a time where this is inconsistent. If you want to get that document right after creating the user, this might not have been fully executed, so this might not exist. So what you want to do is enforce the fact that this exists. And if you want to enforce the fact that this exists, well, guess what? We have transactions. Of course, add transactional work. If you're used to Spring, you can just use add transaction or add transactional. But what you can also do is get a transaction context, which is what I have here, and then do the operation you want to set in the transaction, which is this is the username, this is the user, this is the email, this is the username. So that's some of the stuff that you can do. So it's been running for quite a while. So let's see. Is it? Well, I hope it worked, because it doesn't seem to. Yes, it works. I have so many traces. I hope it's big enough. It's probably a bit too big. So, whoa. OpenTelemetry Viewer, the thing I told you about the traces, the thing that records everything that happens. So here actually it's recording a transaction cleanup window, which is something automated. That's probably gonna, well, clean up the transactions. That's not the one I had in mail, but you can see at 60 seconds, I'm assuming there's a 60-second timeout to a failing transaction, because of course, if I'm creating the same thing over and over with insert instead of upsert, then the transaction is gonna fail, and this is why you have something like this. Let's see, a get. So here I'm using my 16 gigabyte laptop with Couchbase running on top of it and a whole bunch of other things. So when I say sub millisecond, it's in production setup. Here, of course, I have get that took, where is it? You see, took 1.4 millisecond. And that's just one get. If I look at the query, 22 milliseconds for this query, and this is what's been automatically generated by Spring, so you can see how it works. It's good. Can we do better? That's the same one. There's still, I don't think there's ordering into traces, unfortunately. So this one was 22. This one is 17, and it's a much simpler query. So I'm not sure what happens there. Usually the more precise it is, the faster it's supposed to be. Here it's not. I'm assuming my machine is not always it's Windows scheduler and all that stuff's not always behaving right. But basically, the goal was just to show you the differences between those two things. Do we have any questions about this? I think I have like 10 minutes to show you a couple more things that are important to me and that we haven't talked about. Probably just going to show you that and go back to the code. Oops. So we've talked about all of that. One of the reasons Couchbase is known and used, and one of the reasons why we win deals, is because we are great at sync. Synchronizing stuff is hard. And when I say synchronizing things, I'm talking about active-active replication or active-passive replication between databases or cluster. And it's kind of our job to do that. We've won a huge amount of deals because of that. I just realized I've missed a slide. Anyway. I will get you that slide after I explain everything. Cross data center replication, XDCR, that means that we can sync data from one cluster to the other using this protocol called XDCR. You can have all sorts of setups. We have a customer that used to have a ring architecture when they had two active clusters with only the data service because they wanted to do everything with key value, and every SQL query that were not operational, that was more for analytics, was done on two other clusters. And then they had two other clusters for backup because there's so much data that they prefer to be running several clusters if they had a problem instead of restoring a massive backups. So they have like those 6 clusters in rings, and the 2 up front were just to do data, and the 2 in the middle were just to run analytics loads, like SQL queries, analytics queries, and the 2 in the back were just in case of problems, disaster recovery and all that stuff. And they had a copy of each because, again, you know, disaster recovery, if in French we call that alerte pelleteuse, which means that there's a machine that dig the hole in the road and that cuts all the fiber cable from the data center, and so the whole data center is not accessible anymore because some construction worker did a hole where it was not supposed to be, and then you've lost the whole data center. This thing happens, so you need to be prepared. There's a variety of reasons why you want to do that. More recently, one of the use cases we've had is regulation. There's a lot of laws in different countries that allow you to store data on the ground of this country instead of the other. So if it's health data, French health data has to be stored in France. So let's say you had everything somewhere in Germany, and then that law showed up, and all that French data now has to move to a cluster in France. So what you can do is you start a new Couchbase cluster in the French zone, Then you set up an XDCR replication, and you filter it with whatever you want. There's probably a field called country, so you can do if field equals country, then stuff like this. You can do regex, you can do a whole bunch of things to filter that. That's server to server or cluster to cluster synchronization, which is great. You can also do mobile replication. I haven't talked too much about mobile, but we have a local database called Couchbase Lite. It runs on your phone. It's a wrapper on top of SQLite, which is a pretty cool SQL database. But this wrapper allows you to do JSON, it allows you to do SQL on JSON, it allows you to do full text on JSON, and it allows you to sync some of the data to a Couchbase cluster through something called a sync gateway, which is basically a REST API gateway that holds the sync logic, because of course you want to sync everything from your distributed NoSQL database to your phone. That would not make sense. So you have to have some sort of logic. And you also need to have some sort of logic, because if you have something on the phone, phones tends to go offline and online back again. And if you are doing replications, then you might have a conflict. So you also need to have some logic to manage conflicts, which we provide in Couchbase Lite. Basically, the way you resolve a conflict is a business decision. There's rarely any automatic decision you can take to resolve the conflicts. I mean, by default, it's last right wins probably, but then that wouldn't make any sense. So what we allow you to do when there's a conflict, there's a listener that gives you the 2 documented conflicts, or the tree of documented conflicts, and it allows you to, write the business code that's going to do the conflict resolution for you. Sometimes it can be just showing a screen to the user and allowing the user to decide. Sometimes it can be, this user are more rights or permission than the other one, so he's the user that's winning, stuff like this. That's a pretty basic setup. Your devices are connected to a server that's connected to a database. You can do a variety of setups like this. So that was the same one. You can do a bit different. You can have central cluster connected to, synchronized to edge cluster, synchronized to all the devices. You can even add layers and layers in the middle. And that's my favorite one, and that's what usually gets people excited. You can do peer-to-peer replication as well, which is nice. Which means that if we're in the same network, and we all have the same app, and we all know each other, and we have a way to synchronize databases on all our devices automatically. I mean, you don't even have to be in the same network, it just makes things easier. But basically, if you have a public IP here and there's a public IP in someone else's phone and you already know that, then you can set up a replication between the 2 phones. So that's quite fun. You can do some interesting things with this. That's about it. I need to find that slide that I really wanted to show you. I think I've removed it, which is stupid of me. I'll gladly take some question in the meantime. If you have some. Up. That was fun. Don't have any questions? Sure, you have some questions. Do you have some question online? Yeah. Or I'll take some online questions. So that's a good question. Yes and no. I mean, as usual, it's tech. It depends. We have some JDBC and ODBC drivers. The way they work is they map to the analytics service, which is more suited to a table and columns like structure, because basically what we're doing is rewriting the schemaless data into a structured data storage to make it easier to do all those SQL queries. So you could use a JDBC driver for that. is that a good idea to do an operational application? It's probably going to be slower than if you use an SDK with the data service and the query service and our stateful protocol. So we advise everybody to use all our SDKs, Java, Scala, Kotlin, again, not Groovy. C, C++, Go, PHP, Node, Ruby, Python, Go. I think that's it. Not Perl either, which is sad. If you don't want to use the SDKs, a couple of things you can do. We are working on a protobuf gateway for all the cloud native deployments. It's not public yet, but I know it's in the work. So it's the gRPC API basically that would allow you to do it. So the gateway is going to be the stateful component, and then you would use that as an API. We have a data API coming up for Couchbase Capella, which is our managed offering in the cloud. So cloud.couchbase.com, 30 days trial, no credit card required. So that's going to happen as well. And of course, yeah, we have the JDBC and ODBC driver on top of the analytics service. Is it going to be compatible with APA? Probably not. There's probably going to be some edge cases where you will have some problems. I don't expect 100% compatibility. There's always some weird cases that could happen. So I wouldn't use Spring JDBC with the JDBC driver. That would probably be a bad idea. I mean, you can test it. It's not supported. Probably not.
There's another question.
Yes.
Is it possible to extend somehow the database with your own custom, let's say something like store procedures or
Yes.
event streaming?
Yes, that's completely my missing slides, and I need to pull it up. Because the reason everything works automatically is because of a thing called DCP. It's called the Database Change Protocol. And that's what allows us to sync all the services to each other, but also allow us to, through the eventing service, execute functions if something happens. Yeah.
I need you to share your screen.
Yeah, as soon as I found that thing that I've deleted like an imbecile. It's not here. That's too many slides. God. Ok, c'est pas celui-là. So yes, the database change protocol, it's basically our own event streaming solution, internal event streaming solution that moves things around between services. It's pluggable as well. That's plugged into the eventing service. The eventing service is if something happens, document created or updated or document deleted, then I can do something. That something is an uploaded JavaScript function or an uploaded Python function. And you can have, I'm not going to say you can have any code you want because of course there's some security limitation because we don't want you to be able to do whatever you want. It's not the right one. Either.
And so, yes, because you listen to that service, this is all to that change feed. We have some customers that have been created their own Elastic or Kafka or wherever to whatever syncing solution. And so if you think about it, if you can sync to any external service, you can create your own Couchbase service as well based on DCP, and that's the really it's our own eventing service. We've had some people using it to do change data capture, which means that this feed is actually ordered. So if you want to change data capture, it's basically recording everything that happened, every modification, every mutation that happened in the cluster, in order to replay them easily. And that's something you can do as well with DCP. That's pretty recent. That's embarrassing. The same one. Too many slides. You should version your slide, because if you modified it an hour before a meetup, then you would be able to not do what I just did. Yes. Oops. I need to share it as well with the rest of the viewer. Hopla. Are we good? Online? Yes, we are. Okay, cool. So the reason it works is because of that thing called the database and protocol that I've just been talking over and over for 5 minutes. So basically, that's the thing that connects every stateful services. I'm emphasis on stateful because some of the services are stateless. The query service is completely stateless. So if you have lots of query to parse, then you can have as many query nodes as you want and distribute the load easily. So it's stateless. Who cares? It's just going to be more entry in the cluster map being sent to the SDK, so it's fine. And then you have the stateful service. The first one, of course, being the data service, where everything happens, everything starts. Something created, deleted, updated. Start from the data service. To then go through the analytics service, and then you can see that thanks to that analytics service, we get connection to sources that like structured data a bit more. So if you like structured data, like Spark, like ETLs, like Talent, like an ODBC or GDBC driver, stuff like this, Tableau, of course. Connectors to external sources as well, if you don't want to use DCP manually. Or maybe you're already using Kafka to do that kind of stuff, then you can send all the changes to an existing Kafka or Apache Pulsar, whatever. The eventing service is the service that we use for trigger. We call them user-defined function. So JavaScript, Python, that's the only two supported. Of course, it updates the index service and the Fulltext service automatically. And then there's this thing called XDCR, cross data center replication, which is the thing I told you about earlier, which is what allows us to do active-active or active-passive replication between clusters, which is great for a variety of reasons. But if your core business is based on latency, there's one latency you cannot beat. That's the size of the optic fiber between the client and data center. And I know that because I used to work for a cloud provider, and our data center were located in Paris, and one of our favorite customers was in South Africa. And I can tell you that he was having a very bad time because all the latency was from the network trip between South Africa to a Paris cluster. Unfortunately, he couldn't use another zone in South Africa, but with Couchbase, you could very well have an XDCR replication between the cluster in Europe and the cluster in South Africa, and it would dramatically reduce the latency. And latency is important because that's what
gets users to be frustrated, and that's what gets your adoption rates down, which is also why Couchbase Mobile is an important solution. The fact that you have a local database on your phone means that you have data even if you're offline, which means that you have less user frustration. So I don't remember, but I think we had some numbers about user retention, and the moment a company moved to Couchbase Lite, they dramatically increased their retention after the first 2 or 3 weeks, which is where you get the most frustration, and people usually make those kind of uninstall choices. So yeah, everything works. Like the trade-off when we say, oh, we do everything, we're a platform, and people are like, of course you do. The trade-off comes from the complexity of orchestrating all of that, and the simplicity and the fact that DCP is amazing and just works and just synchronize all that together. And so as a developer, you only have one SDK to learn to do all that stuff. And of course, if Future comes up with new way of storing data and more efficient way of storing data and querying data, then it's easy for us to add it to Couchbase, and it's probably easy for you to also create it to your own project, or add it to your own project. So that's the one I forgot about, and that's probably one of the most important, sadly. But yeah, questions? Yes.
Okay. You mentioned before that it supports multi-tenancy. How does it work? It works like each node is dedicated for each tenant, or all the nodes are mixed between tenants?
Well, it depends, right? It depends on the constraint you want to put on multi-tenancy. Sometimes people want to have separated hardware. Well, that's not how it works here. It's the same cluster, the same hardware. So because of where we shard things, there wouldn't be any, I don't think there would be any physical separations on the data service, at least. You would still have to do, probably to run another cluster. But basically, multi-tenancy depends on the constraint. We offer a granularity that allow you to do multi-tenancy, meaning that in a bucket you can have several scopes, and each scopes can have the same collection. So that's usually what we advise people to do. If you have a multi-tenant use case and physical separation is not that important, and all you need to do in your bucket is create one scope for each tenant, and each scope will have the exact same collections. Now, as the index would go, you can shard index when you create an index. You can say, I want this index to be on this node and this index to be on this node. So you could have some sort of physical separation, but that's probably a bit hard to do, or a bit tedious to do.
Okay. Thank you.
I have I don't know, it's simple, but I think it's simple question. I'm from all days for where MySQL and so on, when I can run a MySQL in only one instance, and for all the company.
Yeah.
Is the same for Couchbase? Because
You
in
can
our
run everything
picture
in
I
one
see
instance.
a lot of picture, a lot of instances, but
Yeah, so that goes back to the difference between SQL and NoSQL, and the fact that every SQL database has JSON and every NoSQL has SQL now, so it doesn't really matter. And I think one of the last big difference is that NoSQL has a distributed architecture that's much more recent than SQL databases, which is why you see so many schemas about how great and cloud-ready and distributed Couchbase is, because the architecture is interesting. It's a masterless architecture. It's a I don't want to say scale linearly because nothing scales linearly, but like close to like linear scale. Whereas relational data store, usually you have one leader node that takes all the write, and then you get all the ways to all the follower node, and it's a bit of a different architecture. So I guess that's the main difference. Now, can you use Couchbase to one node setups? Yes, probably. I haven't talked about this too much, but there's a community edition and enterprise edition. The community edition is open source. Anybody can install it. It comes with some limitation, like the fact that multi-dimensional scaling is not available. So you have all services activated by default on each community node. And I think the cluster size is like 3 or 5 max. But yeah, and enterprise, if you want to run one node, yes, you can. That's actually one of the problem I have with sales and products sometimes, is that not everybody needs high availability. But everybody needs a database. So it should be perfectly fine to start on Couchbase Cupola, our cloud offering, with only one node. It's not possible, but we're working on this. We want to have a one node option available. But it would probably change our default SLA, because of course if you use a cloud service, you have a default SLA, and SLA is easier to maintain when you have a distributed system with replicas if something goes wrong than if you have just one node. So different kind of SLA, different kind of problem, different kind of solutions. We're working on this. We want this to be available. We want the perpetual feature to be available. Right now it's pretty expensive to start with Couchbase, manage on the cloud with Cupola because it's 3 nodes minimum. But as a self-hosted solution, if you want to run Couchbase Enterprise in one node, you can. Yeah. And you don't have to activate every services as well. It's usually people are like, I don't need all of that. But the point is, you need something to store data, and usually you need some caching layer in the middle to go fast. That's the most common things we see, is some sort of relational document database with a cache, and then a whole bunch of things that gravitates around that. And the beauty of Couchbase is that you don't have to build everything. You can just build things as you go along, but you won't have to change the SDK. You won't have to rewrite the code. You won't have to learn a new language because it's SQL. Yeah, everybody thinks, God, I don't use all of that. Do I need Couchbase? Not everybody is doing a massive replatforming all the time through just one database. Some people do, usually good for us. But the good thing is you don't need to start with everything. And if you start with Couchbase, it's kind of sort of making you a promise of first allowing you to choose a lot of different things and keep adding things to our architecture, our platform, based on our architecture.
Yeah, maybe this is the aim of the question, because in a small company, a small medium company, at least in my experience, the typical day, the typical fight with the infra people requesting to provision machine. So
Yeah.
to provision a machine, to install a MySQL more or less in these days is very easy. Provision a new machine for something new is is difficult.
It's always
so
harder. Yeah.
Provision 3 machine is a little.
I mean, databases are very structuring choices, so it's always a complicated questions. And of course, not everybody's going to choose a new database. Our main use case when people choose Couchbase for I want to say a business problem instead of an infrastructure problem. I'm going to make a quick digression on this. NoSQL was fixing a business problem at the beginning, which was scale and distribution. That's why people were going to NoSQL, because they had a business problem, so something that they need to be resolved pretty fast, instead of an infrastructure problem, which was, I need to scale up or out, or I need more scale. So NoSQL fixed that, which is why NoSQL sort of existed as a market. And then every NoSQL database got SQL, and every SQL database got JSON and everything. So it wasn't really a business problem anymore. NoSQL got back to being an infrastructure problem, just like any other database. So we are in that situation where, like, I don't really want to manage another database until you come up with a business problem to be solved. And the business problem that Couchbase solved in those cases, mobile is one of the big drivers that we have, because there's very few solutions that are, I want to say, full stack solution, in the sense that you want to have and mobile and web integrated to each other, and that's what Couchbase allows you to do, like with this platform approach. And the fact that we have a local database that syncs automatically, that's a business problem, not infrastructure problem. So that's one of the business problems that we solve very easily. The other one, is it business infrastructure, is the fact that we are multimodal and that everything is fully compatible with SQL. It's that Elastic query example I gave you. The fact that you have to query Elastic and then you have to query your database, it's sort of that simplification can be seen maybe as a business problem more than infrastructure problem, because people are tired of having all those different solutions. But again, it's like, who needs to do replatforming all the time? And it's a difficult question.
I have another one.
Quick question. Just curious. the Spring Data Couchbase module, do you guys maintain it, or this is maintained by the Springboot team?
No, it's maintained by us. We have a team that's well, it's basically the SDK team that maintains it. We also have another team that maintains cool projects. One of them I haven't showed you is the JetBrains plugin we have. So you can connect to a local database. You can browse the local database. I can see my users. I can modify my users in place. There's a whole bunch of things you can do. You can run query. Let's say I'm gonna get into the default scope and I'm gonna show you. This query is actually pretty interesting. So we have a plugin. It allow you to do a bunch of things like running queries. When you run a query, you can see the query plan visually, you know, seeing what happens. Is it using my indexes and everything, which is pretty cool. So for instance, here you can see that there's a filter based on the ID of the document, and then there's an operation called nest. I haven't talked too much about what makes R SQL JSON friendly. But here I have on that file. Where is that file? Actually, let me find that file. I have a file. It has a field called nested comments, and it's an array with 1 and 2. And actually 1 and 2 are the ID of documents that are stored into the comment collection, which are those 2 documents. And so what I've been doing with my query somewhere is nest those comments. What have I done with that thing? All right, it's okay. Go back to that query. All right, so a nested comment was the array with 1 and 2. Okay. Comments is the name of my collection that you see on the right that has ID 1 and ID 2, and the array contain 1 and 2. So when I say nest comments, C, it's going to be on the field called C. What I have is all the field of my document, because I did this for some reason, which was stupid. But I also have a field called C somewhere. Probably, or comments actually. The name is called comments because I said C as comments here, and that's what you see here. It's nesting means I have an array of IDs. I'm going to get those documents and I'm going to nest them into the actual answer of my SQL query. So that's what you see here. The document 1 and 2 with what it was just 1, 2 are now document 1 and document 2. So what that means is that we have a JSON language that allows you to profit from SQL as much as possible, because you know that SQL has arrays and objects of arrays and arrays of objects and all those weird structures. So all of them are accessible through nest. A nest is basically a left outer join. It's the opposite of nest. So you have an array of things and you can flatten them so you can join them to something else. Of course, we have joins, all sorts of joins. When you do a join, you do a join on something, so on the field. So we encourage people to create secondary index on the field that is going to be used for the join. You can do component indexes. I mean, there's a variety of things that you would expect from SQL and not necessarily from the SQL that you can actually do with Couchbase. So it's pretty cool. So yeah, our team are managing all those external projects, Spring Data, the JetBrains plugin. We have another thing called Automan, which is an ODM for Node.js. It's sort of the mongoose of Couchbase. And they also maintain the VS Code plugin, and like there's a bunch of integrations that are maintained by us. Some vendors have tried to do, when we get into this discussion with vendors, it's usually they say, oh, let us do it, we know what we're doing, but most of the time it's better when it's the vendor, when it's the solution to be integrated that actually do it than the vendor. Like our JetBrains plugin, it's miles away from the data group integration that we have on the JetBrains IDE, for instance, because we did it. You had a question?
Yeah. In terms of backups, does it support backups? Because it is already distributed, so it's...
Yeah, it does support backups. There's a couple of different tools. One of them is only available in the Enterprise Edition. And it can back up things straight up to S3. It can back up things incrementally, differentially. I mean, there's a bunch of things you can do. You can choose the granularity of the backup. You can back up the whole bucket. You can back up just collection or a bucket or anything. And you can loosely use the import and export function actually from the. I wouldn't expect anyone to do backup like this, but just know that you can actually export things from here as well. It's called simple export, simple import, but you can do stuff from here as well.
Okay, last one. Does it save the data cipher at rest or?
Oh, so encryption.
Yeah.
You can do encryption at rest if you want to. Everything that moves around, so all the stuff that you've seen through DCP or from when you do an active application, everything's encrypted. So everything's encrypted at rest. If you want more encryption, we support client field encryption. So that means that only the client has the key to decipher the field, and you will synchronize, you will write the encrypted field to the database. We don't support querying encrypted field, unfortunately, yet. Some people do, we don't. Mm-hmm. But you can store encrypted field on the server. Is it super useful on the server? I don't know, but it works on mobile as well. That's great, that's amazing, because the data that you want to sync is usually on your device. It's usually personal data, so that might as well just be encrypted instead of fully available.
Yeah, thank you.
More questions?
It's pretty good. Nothing online?
Okay, thank you very much.
Thank you.
Big applause for him. If you can switch back to the presentation that we shared with you in the beginning. Don't close that. Yes.
I think
It's on the calendar, probably. On the calendar appointment you used to have, or
I will have it here, I think, I guess.
yeah, that's the one. Yeah. Okay, that's yeah.
Perfect.
So I don't know if I should keep it in English or can I switch into Spanish. I don't. We are going to do the final announcements that we usually do. So okay, as you know, we always try to say what's coming up, what are the next sessions that we are holding, and basically, what's coming up is December, which is a very tough month. First, because of course we have the Christmas break. And we are not planning to do anything except spending our time with family and probably hacking something, but that's up to you. So we are not going to do any meetups there. We also have this week, which is not the best week to do anything because we have 2 holidays there. And then probably most of you are going to have a lot of parties at your company. So that only gives us a week to do something, but we are not going to do that anything on that week this month. Because actually there's another thing we are going to introduce that later. We are, by the way, planning, in case anyone is watching, we are planning to do something at the university because we are trying to reach out to more students and bring more students, put more students in contact with the Java user group and the Groovy user group. And we are planning to do something with also Scala Madrid and some other communities. So because what we are trying to do is trying to put them in contact with the real world. So if you know any students, just let us know, because we are in touch with a couple of universities, and we are going probably to do something with them. So that means that we are not going to have any meetup in December, but still there is something that you may be interested in, which is basically on that week, the people from CodeMotion are organizing a Technitag with Afternoon Tour. And actually Jorge Hidalgo is coming from Malaga. He's the leader of the Java user group in Malaga also. And the topic is really interesting, so we are going to be there. So we encourage you also to go there. There you have the URL in case you want to register, and well, see you there. So a couple of more minutes so that you can screenshot the QR code. You done? Okay, more things. Oh, animations, right? Yeah. This is what happens when you create them. So something is coming on that red box. But for now, I don't know how many of you know about the advent of code. A few people. How many of you are planning to do the advent of code this year? Less people. I'm also going to do that because as we had a Kotlin introduction this month, I'm planning to do the advent of code in Kotlin. So that's also a nice excuse to try something different. So the thing is, we have created an account and we are planning to...
That's actually good to read about it. That's a good advice.
We are going to create a leaderboard, a private leaderboard. So if you want to just share what you are doing or just try to, I don't know, to be in contact with other people trying to do the advent of code, depending on if you are doing that in Kotlin or trying to use functional programming or trying to, I don't know. You can share that, and you can also join that private leaderboard, so to share and compare what you are doing. So this is, well, this is not advent of code. This is, well, this is, sorry. The title should be the Slack channel. So something went wrong. So basically, we also have a Slack channel. This is something that we already had from 2015 or something like that. It was long before the pandemic, and actually the Slack channel is called Comunidad Hispana de JAX. So this is something that we use when we were doing these hack days together with some other Java user groups from South America and all other Spanish-speaking countries. So it's a great thing. It was kind of dormant, but we are trying to restart it because, in fact, there are already a lot of people there. So just use the QR code if you want to join, and then join the Madrid Yak channel. Of course, introduce yourself, say hi, and probably say what are you working on, what are your favorite languages. And also we have created another channel just to share any progress or any ideas or any thing that you want to share about the advent of code. More social things. Remember that we have also, this is something that we announced every once in a while. We also have a group for all of you that usually ride your bike or do running or something. We have created an Strava group so that you can join. We are planning to, at some point, maybe we are going to do some kind of conference while we ride our bikes or something crazy. We will see. But for now, if you want to share your rides, that's a group that we have. Also, that's something that we include in every presentation. Remember, we have an open collective both for the Java user group and the Groovy user group. This is basically very interesting because now you can see how many money does cost to run a Java user group, which is not much, but it's we are transparent on the things that we are doing, like, for example, paying for the account that allow us to do the streaming, or to pay for our Meetup account. And basically the idea of creating this open collective channel is something that was suggested by our friends from the Madrid Java user group. And basically this allowed us to also share the money, because before we were just paying by ourselves and we were gladly paying for that, but now we can also, anyone can share that burden. So, and we don't need money, because actually we are really thankful, because we have been receiving some contributions by people that are watching us, or by companies, or by any of you. So thanks to that, we are going to probably do something, because we have already paid our Meetup accounts and the StreamYard accounts and all the things that we need to run our infrastructure. So now we may be able to create some stickers or night t-shirts or mugs or something that we can also raffle at the end of our presentation. So thank you for contributing. And before this, this is the usual moment in which we close the streaming. We are going to say goodbye to the friends that are listening to us. Hope to see you next time, and then we are going to stay here to raffle a couple of things that we have for the people that is attending in person.